Welcome to part 2. So in part 2, we are going to look at another example. So I want to find the exact value of each of the following under the given condition. So for A, B, C, D, I have sine alpha plus beta, cosine sine alpha minus beta, and 1 for tangent. If you think that the number is too confusing, you can take that as number 1 and that as number 2. So for number 1, I have a sine alpha and a cosine beta. I gave you the domain of alpha. However, using a sine alpha and cosine beta, that is not enough to find the exact value of parts A, B, C, and D. To do this, let's start with the problem. So number 1, I have sine alpha equals to 3 over 5, and alpha is between 0 and pi over 2. So 0 and pi over 2, that is in quadrant what? That is in quadrant 1, where x and y are both positive. So we are going to draw a coordinate, and then positive, comma positive, those that represent x, comma y. And then cosine beta, that is equals to 2 root 5 divided by 5, and then beta is between negative pi over 2 and 0. Negative pi over 2 is 90 degree clockwise. So this one is in quadrant 4, where x is positive, y is negative. That is important for the next step. So for the next step, before we move on to the problem solving, I have to review a very important thing of trigonometry. So this is what we have to review. So right triangle trigonometry. What is right triangle trigonometry? Right triangle trigonometry is SOH CAH TOA, SOH and TOA. What is SOH CAH TOA? Let me give you a picture. So right triangle, right? First, we have to draw a right triangle. Right triangle means one of the interior angles is 90 degrees, a right angle. This side, we call this hypotenuse. And then this is where the angle is, and this is called adjacent. And then this is called opposite. So for sine of theta, we have opposite divided by hypotenuse. So that's why we call that SOH. So, and then CAH, that is adjacent divided by hypotenuse, and then tangent, that is opposites divided by adjacent. And then on the other side, we have cosecant theta, that is hypotenuse divided by opposite, and then secant theta, that is hypotenuse divided by adjacent. So what we are doing is because cosecant is the reciprocal of sine, right? So basically for cosecant, you look at the side and then just swap the top and bottom. And then cotangent theta, we have adjacent divided by opposite. So that is the SOH CAH TOA. And then for right triangle trigonometry, there is one other important character, another one important theorem that is called the Pythagorean Theorem. What is Pythagorean Theorem? You have a right triangle. So that is a right triangle. Pythagorean Theorem describes the relationship between the two sides. So this is A, this is C, this is B, and then this is A. What is the relationship between them? The relationship between them is that we have A squared plus B squared equals to C squared. That works for right triangle only. Okay, for right triangle only. What if the triangle is not a right triangle? Then we have another formulas to describe the relationship between the three sides and the three interior angles. We will get to that in another lesson. So going back to this problem, so we have to take the given, what is written in purple. So let's go back to purple. I am going to rewrite that again for you. So we have sine of alpha equals to 3 over 5, that is opposite divided by hypotenuse, and we already said that this is in quadrant 1, so we put a right triangle in quadrant 1. So this is hypotenuse this is opposite, and this one is x. So since because we don't know what it is, so this point is x comma 3. And then this is the angle alpha. All right, and then for the other one is in let's write down right out first. So cosine of beta, that is 2 root 5 divided by 5. So CAH, right? So adjacent divided by hypotenuse. And then we draw a triangle in what quadrant? In quadrant 4. So in quadrant 4, we do that. This is a right triangle. And then we have this. This is a 2 root 5 adjacent and then hypotenuse. And then this one we don't know. This is a y. So we have x is actually not x. The x value is 2 root 5. The y value is y since we don't know what it is because y is in quadrant 4. Y must be negative. Now, let's find the x and y. All right. So this is a right triangle. This is a right triangle. So for the one on the left, what do we have? We have x squared plus 3 squared equals to 5 squared, right? So we have x squared equals to 25 minus 9 equals to 16. X is equals to the square root of 16. That is equals to 4. This is a positive 4. We don't take care of the plus or minus because in quadrant 1, x is negative. That's why the quadrant is so important. If the first triangle is in quadrant 2 or quadrant 3, then x will be negative. Then we do not keep the positive then. For the y, we have 2 root 5 square plus y square equals to 5 square. So y square is equals to 25 minus 2 times 2 is 4. Root 5 times root 5 is 5. 4 times 5 is 20. That is equals to 5. So take the square root on both sides. This time we have to keep the negative because y is in quadrant 4. In quadrant 4, y is negative. So now we have all the x and y. So this is equals to 4. This is equals to negative root 5. So now I can write the sine, cosine, tangent using this right triangle. So using the SOH CAH TOA. So you have the right triangle, right? So now I am going to recall the SOH CAH TOA. Okay, so using this right triangle, I am going to write the sine, cosine, and tangent. So let's do the one on the left. So for alpha, we have sine of alpha equals to 3 over 5. That is given. And then cosine of alpha, CAH, right? So that is the adjacent divided by hypotenuse, 4 over 5. And then tangent is easy. So for tangent, you take the sine divided by cosine. So that is 3 over 5 divided by 4 over 5. That equals to 3 over 4. And then the other side, we have cotangent beta that is given in the problem. So that is 2 root 5 divided by 5. And then a sine of beta, SOH, that is a negative. Just look at the triangle. We have a negative root 5 divided by 5. And then we have sine and cosine. Figure out tangent is super easy. So for tangent beta, we have sine divided by cosine. Okay, so the denominator are cancelled, and then the root 5s are cancelled. So this is just equals to negative 1/2. Or you can take the top divided by the reciprocal of the bottom, and then you cancel out the terms. Okay, so now we have all the ingredients right here. So we have all the ingredients right here. This is what we need to figure out part A, B, C, and D. Let's do part A. So for part A, they asked me to evaluate sine of alpha plus beta. So we go ahead and then we write the formula out. So don't just plug in the numbers, write the formula out. Sine alpha and then cosine beta, this is the sum formula for sine. And then plus cosine alpha, sine beta. And then all you have to do is you plug in. So this is equals to 3 divided by 5 times 2 root 5 divided by 5 plus 4 over 5 times negative root 5 divided by 5. You get a common denominator. Perfect. So that is a 6 plus, it's not actually a plus, you have a negative. So that is 4 root 5 divided by 25. 6 minus 4 is equals to 2. that's it. This is your answer. Do not use a calculator to approximate this. The purpose of doing this is pushing you to do all the fractions. If you use a calculator, basically you get no points. You have to go through the fractions, all right? Do not use a calculator. You have to give me this exact value. For part B, you have cosine alpha plus beta that equals to cosine alpha, cosine beta minus sine of alpha, sine of beta. And then you have 4 over 5 times 2 root 5 divided by 5 minus 3 over 5 times negative root 5 over 5. So you have 8 root 5 divided by 25 plus 3 root 5 divided by 25, right? You have 2 minuses. And then 8 plus 3 is 11. And then moving on to C, so this is your final answer. Moving on to C, you have sine of alpha minus beta that is equals to sine of alpha cosine of beta minus cosine alpha sine beta. And then you plug it in. So this is your ingredient, right? In this box, you just take it, plug it in, clean up the math, the job is done. So sine alpha, you have 4 over 5 times 2 root 5 divided by 5 minus 3 over 5 times negative root 5 over 5. You have a common denominator again. So this is 8 plus 3. Then that is equals to 11. So that is a C. And then we have a D. So D is tangent alpha minus beta that is equals to tangent alpha minus tangent beta. This formula, to be honest, we don't really see that in calculus all the time. Tangent alpha, tangent beta, and then you plug it in. It's part of the lesson, so you have to learn this anyway. So that is a 3 over 4 minus negative 1/2. These numbers, they are not from nowhere. Where are these numbers from? These numbers are from here, right here. I use a right triangle trigonometry SOH CAH TOA to get these numbers out. And then all I am doing right now is plug in. You have to be careful. If your SOH CAH TOA is wrong, then that is going to carry over to all subproblems. So if your SOH CAH TOA is wrong, then every single subproblem will be wrong. 1 plus 3 over 4 times negative 1/2. So that is 5 divided by 4, 5 divided by 8, and then this is the top times the reciprocal of the bottom, so that is just equals to 2. So that's all for the first part. All right, so that's fun, right? So let's do one more, because one problem is never enough. For the next problem, I am going to switch color. So which one should I pick? Let's pick a green, shall we? So in part B, we have tangent alpha equals to negative 4 over 3, and then alpha is between pi over 2 and pi. Where is this? Pi over 2 and pi, that is in quadrant 2, where x is negative, y is positive. They don't tell you this in the problem. It is your job to figure it out. And then they gave you a cosine beta equals to 1/2, and then a beta is between 0 and pi over 2. 0 and pi over 2, that is quadrant 1. So we have a 2 plus, and then now we state the givens, and then we draw a right triangle, and then apply the SOH CAH TOA. So first, we have tangent, right? We have tangent alpha. What is tangent? TOA, opposites divided by adjacent. So that is negative 4 over 3. And then you draw a right triangle. I just said that is in quadrant 2. So you put your right triangle in quadrant 2. So that is your quadrant 2. This is a right triangle. And then this is my alpha. That is the opposite of alpha. And then this is a negative 3. Why is this a negative 3? Because at this point, at this mark, x is equals to negative 3. Again, quadrant 2. And then the hypotenuse, you can call this r. But this is not a unit circle. Why? Because the radius of the circle is not equal to 1. You cannot guarantee that r is equals to 1. That is impossible. All right, we have to figure out r using the Pythagorean theorem, but at this point, so r is a radius, but we are not using a unit circle, so we don't need to worry about this. Let's do the cosine beta. So we draw cosine beta, see what's SOH CAH, right? So adjacent divided by hypotenuse, that is equals to 1/2, and then this is in quadrant 1, so we draw a triangle in quadrant 1, right triangle, this is your beta, and then adjacent to it is 1, hypotenuse is 2, and then what is this? This is a y, right? So this point is 1 comma y, and then this point is -3 comma 4. Let's do it. So the radius, hypotenuse, we have 4 square plus -3 square equals to r square. So this is a 9 plus 16, we get a perfect square, so that is a 25. Square root of that, we have a 5. Our radius is always positive. It doesn't matter what quadrant that is in. R, the radius, the hypotenuse, is always positive. All right? Always positive, always. And then on the other side, I have 1 square plus y square equals to 2 square. So this is y square equals to 4 minus 1, right? Equals to 3, so y is equals to the square root of 3, positive or negative. The answer is positive because y is in quadrant 1. So now we have the length of each side of the right triangle. And then we apply SOH CAH TOA to write the sine, cosine, tangent, one for alpha and one for beta. So we call the SOH CAH TOA SOH CAH and then TOA. So for sine of alpha, we have what do we have? SOH, right? So S is OH, so opposite is 4, hypotenuse is 5, so that is a 4/5. And then cosine alpha, CAH, so A is 4, H is 5. Oh, actually, sorry, A is a -3, H is 5, and then tangent is given, so that is -4/3. And then cosine of beta, that is equals to 1/2, that is given, and then sine of beta, SOH, so opposite is √3, and then hypotenuse is 2, so that is √3 divided by 2, and then tangent beta, that is TOA, right? So opposite divided by adjacent, so that is √3 divided by 1, or you can take the sine divided by cosine, you get a √3. So this is the ingredients that we need to do part A to D. All right, when I do the plugin, the numbers are not from middle of nowhere, they are from here. This is my ingredient table. Let's do the 4 parts. So in part A, I have sine of alpha plus beta, and then you just state the formula, or we call the formula sine alpha cosine beta plus cosine alpha, and then sine of beta. And then what do we have? Just plug in. So you have 4/5 times 1/2 plus -3/5 times √3 divided by 2. And then you have 4 times 3/3 divided by 10, because this is a 4, right? The denominator is 10. This is a 4 minus 3. Or another way to write this is 4/10 minus 3/3 divided by 10. Either one is fine, okay? But if you have this, then just that is good enough. There is no reason to break it down into 2 pieces. And then in part B, you have cosine alpha plus beta, that is equals to cosine alpha cosine beta minus sine of alpha and then sine of beta. So that is equals to, plug in. So -3/5 times 1/2, and then minus 4/5 times √3 divided by 2. Okay, so this is negative 3 over 10 minus 4 root 3 divided by 10. That is good enough. Or you can write that as negative 3 minus 4 root 3 divided by 10. Either one is fine. And then part C, you have a sine of alpha minus beta equals to sine of alpha cosine of beta minus cosine alpha sine of beta. Plug in. So you have this written on your paper, right? Plug in. So 4 divided by 5 times 1/2 minus 3 over 5 times root 3 divided by 2. And then this is a 4 over 10 minus, is not minus, is a plus 3 root 3 divided by 10. All right, that is your answer. Or you can write 4 plus 3 root 3 divided by 10. And then part D, you have a tangent alpha minus beta. That is tangent alpha minus tangent beta divided by 1 plus tangent alpha and then tangent beta. Plug in. So this is negative 4 over 3 minus root 3 divided by 1 plus negative 4 over 3 times root 3. So this one we have to get a common denominator on top and bottom. They are all 3. So this is a negative 4 minus, for the root 3, you have to multiply top and bottom by 3, right? So that's why you have this. And then the denominator, the 1 you have to multiply top and bottom by 3, you have 3 minus 4 root 3. And then you take the top divided by the bottom, or the top divided by the reciprocal of the bottom. So that gives you one thing, that is equals to negative 4 minus 3 root 3 divided by 3 minus 4 root 3. You can take that as a final answer. However, in some classes, you are not allowed to have a radical in the denominator. So what you have to do is you have to multiply a conjugate to get rid of the square root in the denominator. So the conjugate is 3 plus 4 root 3. 3 plus 4 root 3. This is called conjugate. What is called conjugate? Conjugate means you take the opposite sign of the denominator. I don't care what's on top. I only care the denominator, all right? So if that is a minus, you take a plus. If this is a plus, then you take a minus. These two signs must be opposite. And this conjugate, another way to represent the conjugate is a magic one. Because any fractions multiplied by 1 equals to itself. You multiply this conjugate is equals to 1. Any quantity multiplied by 1, you don't change that quantity. You only change the outlook of it. So going back to the problem. So this one is just like you have A minus B times A plus B. You are opening up the multiplication of two factors. So that equals to A squared minus B squared. Right? It's multiply. You don't take the negative 4 root 3 times 3. No. You have to multiply like this. So A times B, A times A times B, minus B times A, minus B times B. You have 4 fractions to do. So you open that up. What do you have? The denominator, you have a 9 minus 12 times 3. The top you have a negative 48 minus 25 times root 3. And then you have negative 39 and then negative 48 minus 25 root 3. If you want the answer look better, here is how we are going to do it. You factor out a negative 1. So this is a 48 plus 25 root 3. And then negative 39. You cancel out the negative 1. You have 48 plus 25 root 3 divided by 39. So that is your final answer. So that will be all in this lesson. So for the next part, in part 3, I will teach you how to prove trigonometric identity using the sum and difference formulas. All right, I will see you there.